Our next lesson in this unit is on exponential equations. So to solve equations using exponentials, the first method is what we already know how to do from last unit. This is when we're going to convert to a common base and just solve. What we're learning this unit is what to do if there is no common base. So what we're going to do if there is no common base is to rewrite our equation with one term on each side. And then we're going to take the common or natural log on both sides and then rewrite using the properties of logs. And then we're going to solve this. So let's take a look at number 1. So for number 1, we should first try to see if we can convert to a common base. So in this case we can. 3 and then 81 is 3 to the 4th. So once we change them both to the same base, now we can just bring down our exponents. So x plus 1 equals 4. Right, minus 1, we know that x is equal to 3, and we're good to go. So very simple when our bases can be converted to a common one. Let's look at number 2 now. So when we have 2 to the x equals 5, so 2 and 5 we cannot convert to a common base. So what we want to do is rewrite our equation with one term on each side. So we already have one on each side. This is 2 to the power x, this equals 5, so we're good to go. What we're going to do now is take the log of each side. So this is going to become log of 2x equals log of 5. Once we've done this, so we're taking the common log, so just log base 10, so we don't have to write the base 10. Once we've done this, now we can use our properties of log. So this is our exponent. Our x is our exponent, so we can bring that down in front. So this turns into x log of 2 equals log of 5. And now to solve for x, we're trying to get x by itself. So we just need to get rid of log 2 by dividing by log of 2. So x is equal to log of 5 divided by log of 2. And this is now where we're going to take out our calculators to get an exact answer for this one. So in your calculator, we're just going to type in log 5 divided by log of 2. Press enter. And we're going to round to 3 decimal points. So for number 2, our answer is x equals 2.322. And that's our final answer. Let's look at number 3. So for number 3, we have 8 times 3 to the power x equals 5. So unlike number 2, there's something we need to do here. We need to first get rid of this 8 before we can take our logs. So to get rid of this 8, what I'm going to do is divide by 8 to get the exponential function on its own. So this turns into 3 to the x equals 5 over 8. And now that I have one term on each side, now I can take the log of both sides. So this is log of 3 to the x equals log of 5 over 8. So just like before, this is my exponent, so I'm going to move it out in front. So this becomes x log of 3 equals log of 5/8. And again, to get x by itself, I'm going to divide by log of 3. And so x is equal to log of 5/8 divided by log of 3. And again, I'm going to put this in my calculator. So type in log of 5 divided by 8, close parentheses, divided by log of 3. And this is going to give us our answer, which is negative 0.428, or round to 3 decimal points. That's my answer. Okay, let's look at one that's a little bit more complicated now. So if we go up to number 4. So we have 2 exponents on either side. So notice the 5 and the 3 we can't rewrite using the same base. So we're going to take the log of both sides. So we already have just one term on both sides. So this becomes log of 5, x minus 2, equals log of 3, 3x plus 2. So just like before, we're going to take our exponents and move them to the front. But this time our exponents are a lot more complicated. So our exponent is this x minus 2. So this is x minus 2 times log of 5. Over here I have 3x plus 2 times log of 3. So I'm bringing both my exponents out in front. Notice for this one, there's two terms. So what I'm going to have to do next is distribute my log of 5 to both of these terms and my log of 3 to both of these terms. So this turns into, I have x log of 5 minus 2 log of 5 equals 3x log of 3 plus 2 log of 3. So I distributed my log 5 and log 3. My next step here, so this is kind of like the unit we did with inverses, where if we're trying to solve for x, we need to get our terms with x in it on one side. So what I want is all my terms with x onto one side and everything else on the other one. So I'm going to move this term over here onto this side. And then I'm going to move the minus 2 log of 5 over to the other side. So what this does is it leaves me with both my x's on this side. So I have x log of 5 minus 3x log of 3 equals, and now I have these two over here. So 2 log of 5 plus 2 log of 3. So now both my x's are on one side. What I'm going to do next to get x by itself is to factor out an x. So when I take out an x, this leaves me with log 5 minus 3 log 3. And this is equal to 2 log 5 plus 2 log 3. Okay, so what I want to do next is I want to use my log rules to combine everything. So this is similar to what we did in our other lesson. So let's start off with these 2. So this 2 I can actually move to become an exponent here. Right, same as this 2, I'm going to also move to become an exponent up here. And this 3 also becomes an exponent as well. And now I'm going to rewrite some of these. So this x still stays here. I'm going to turn this into 1 log. So if this is being subtracted, when I write it as 1 log, this is now going to be 5 divided by 3 to the third, which is 27. Equals, in this case, to turn it into 1 log, this is being added. So this is 5 squared, which is 25, times 3 squared, which is 9. So this is now 1 log. And to solve this, now I'm trying to get x by itself, I just got to divide by log of 5 over 27. So that's going to cancel out. This divides by log of 5 over 27. And this is what I'm going to put into my calculator. So I have log of 25 times 9 divided by log of 5 divided by 27. Enter. And this gives me my answer, which is negative 3.21 rounded to. And that's my exact answer for this problem. Okay, one more problem for number 5. This is the first one where we have an e. So again, we first need to get the exponential function by itself. So I'm going to get rid of this 500 by dividing. This leaves me e to the 0.3x equals 600 divided by 500. I can just simplify to 6 over 5, right, since all those zeros cancel out. And now, since we have an e, instead of using log, we're going to actually use ln. So we're going to take ln of both sides, the natural log of both sides. And when I take the natural log here, my natural log and my e cancel each other out to give you 0.3x. And this is ln of 6 over 5. And now to get x by itself, this is very simple. We just divide. And we're going to have natural log of 6 over 5 divided by 0.3. And we're going to do that in our calculator. So be careful, you're putting in natural log 6 divided by 5 divided by 0.3. And that gives us our answer. which is 608. And that is my final answer for this problem.